Okay, for the next video, I'm going to be talking about dealing with radicals. Okay, so I'll be referring to this sheet. Okay, I'm going to put the perfect squares after 1. Perfect squares after 1. Those are 4, 9, 16, 25, 36, 49, 64, blah, blah, blah. Okay? Oh, there's room. So 64, 81, 100. Okay? They're the results of numbers times themselves. So, to simplify a perfect, and then I'm going to put perfect cubes down here. They are 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, and so on. Okay? Now, example 1 of perfect squares. I'm doing the square root of 40. What you do, and I'm going to grab a calculator, is you find the highest number on this list which divides 40. Now, 40 is divisible by 2 and 20, but none of those are perfect squares. Okay? So, 40 is even, so we'll try 4. So 40 divided by 4 gives me 10. Okay? Now, 10 is not divisible by any number on this list, so I went high enough. I put the perfect square first, and then the division result second. And the square root of 4 is 2. And that gives me the square root of 10. I'll leave that one alone. Okay? Example 2. I believe I had the square root of 54. Okay? Square root of 54. Now, when we think factors of 54, you might think 2 and 27, or, well, 227, 18 and 3. But remember, it's got to be divisible by a number on that list. It's not divisible by 4, but it is divisible by 9. So we'll put the 9 first, and 54 divided by 9 is 6. Okay? Square root of 9 is 3. So I have 3 square root of 6. Okay? I'm going to move this over so I can fit more examples on the board. Or more examples on the screen. And the tables that I'm using are uneven, so I apologize for the bumping. Okay. Example 3. The square root of let's do square root of 112. Okay, so I'll try the square root of 112. I will take 112 and divide it by 4, and I get 28. Okay? So, 112 divided by 24 gave me 28. Well, 28 is divisible by 4, so I didn't go high enough. So now I'll try 112 and divide it by 9. Well, it doesn't divide evenly, so that doesn't work. Now I will try 112 and divide it by, so 4 gave me 28, which was divisible by 4, so that wasn't high enough. So now I try 9. I tried 9, it didn't work. So now I try 16. Division by 16 gave me 7. And 7 isn't divisible by any number on that list. So I will use the square root of 16 and the square root of 7. Okay? The square root of 16 is 4. I will leave the square root of 7 alone. Always use the highest perfect square. Okay, so next up, I'm going to do example 4, which also is not on your paper. And I'm going to throw a variable in there. So I got the square root of 56x to the 34th. I'm going to split that up into the square root of 56 and the square root of x to the 34th. You can do that. You can split this up into the product of two square roots. You can do that. Now, the highest perfect square that divides 50, when people think factors of 56, they normally think 8 and 7. But neither of those numbers are on this list. Okay? So, I'll try 56 and divide it by 4. Now, when I divided by 4, the division result was 14. 14 is not divisible by any number on that list. So I went high enough. That's the square root of 4. That's the square root of 14. Now x to the 34th is going to be changed to 34 halves as an exponent. So square root of 4 is 2, square root of 14, and then this will be x to the 17th, which gives me 2x to the 17th times the square root of 14 when I rearrange the multiplication product to have the radical last. Okay, now I'm also going to talk about the perfect cubes, simplifying difference of cubes. So example 1, I had the cube root of 40 this time. Not the square root, the cube root. Okay? Not the square root, the cube root. So I look for the highest perfect cube that divides 40. And that's 8. And 40 divided by 8 is 5. Don't forget the cube root in the notch. The cube root of 8 is 2. So I have 2 cube root of 5. Okay? Example 2. I got the cube root of 54. All right, so that's different from here. We don't use 9. We use the perfect cubes. So 54 divided by, I'll start with 54 divided by 8. 54 divided by 8 gave me 6.75. Okay? So, that doesn't divide evenly. So now I will try 54 and divide it by 27. I got 2. Okay? Which divides evenly. So the cube root of 27 times the cube root of the division result 2. And the cube root of 27 is 3. So I have 3 cube root of 2. Okay? All right. So now I'm no longer going to be dealing with what's on the paper. I'm going to be talking about an unwritten, a document that I'm not going to that I don't have at present to refer to. It's part of a larger document. Rationalizing single term denominators. Okay, rationalizing single term denominators. Step 1. Multiply top, bottom, by denominators square root. Simplify if needed. Okay? So example 1. Let's say I have 2 over the square root of 3. So I'll simply do multiply top and bottom by the square root of 3. Well, down here, you're going to have the square root of 3 times the square root of 3. Well, that's the square root of 3 squared, which just leaves you 3. Okay? Square root, you got the square root squared. That'll leave you the radicand, which is 3. And this is 2 times the square root of 3. And that's as far as that can go. Okay? Example 2. Let's say we have 4 over 3 square root of 5. Well, that would be 4 over 3 square root of 5, and we're going to multiply top and bottom by the square root of 5. So, down here, we're going to have the square root of 5 times the square root of 5 is just 5. That's also going to be multiplied by 3. So square root of 5 times square root of 5 is 5. And up here, we're going to have 4 times square root of 5. And the final result of this will be 4 square root of 5, and 3 times 5 is 15. Okay? Example 3. Square root of 9 over 7 is the square root of 9 over the square root of 7, which is 3 over the square root of 7. Okay? So, 3 over the square root of 7, that's similar to this problem. You'd multiply top and bottom by the square root of 7. So, square root of 7 times square root of 7 is just 7. 3 times square root of 7 is what you're going to have up here. Example 4. I'm going to have to bend this down to reach probably. Okay. So here, I've got the square root of 30 over 13, which gives me the square root of 30 over the square root of 13. Okay? So square root of 30 times square root of 13, you are going to multiply top and bottom by the denominator's square root. So 13, 13. So square root of 13 times square root of 13 is just 13. You're going to multiply the numbers under the radical. So you're going to have a square root of 30 times 13 is 390. And that is it.